Hey everyone, Mr. Fritz here, and in this video we're going to talk about unit vectors and something called unit vector form. We've talked a lot about magnitude and bearing form, we've talked about component form, and we're going to introduce a new unit vector form right now. In general, a unit vector is any vector. Think about the unit circle. A unit circle means that the radius is all equal to 1, unit means 1, so unit vector is any vector which is 1 unit long. So we know some example vectors that are 1 unit long, and really that's the horizontal component vectors and vertical component vectors. If we make those just 1 unit long, that's a unit vector. So here's an example. This vector A is a unit vector because it is just one step in the horizontal direction, and that's it. So the length you can see is just 1. Here's another vector that's a unit vector. That's going to be square root of 3 over 2 and 1/2. And hopefully that's looking kind of familiar. These are the xy coordinates for your special trig value. So this would be like the sine of 60 degrees. And think about the sine of 60 degrees on the unit circle. If it's on the unit circle, that radius is equal to 1. That means that your vector would be equal to 1 if it starts at the origin and ends on that circle. So really you could take any of your unit circle values, and now that's a unit vector. So the square root of 2 over 2 and the square root of 2 over 2, that's another unit vector. Thinking about the magnitude of this vector, that's how I would find whether or not it's a unit vector or not. So, I mean, another way of putting all of this stuff is we're talking about the length. If it's 1 unit long, we could say this is 1 unit in magnitude and 1 unit in size, all the same thing. So think about how do we find the size or magnitude of a vector. And really what we do is we use the Pythagorean theorem. So if this vector C, or let's say this vector B is a unit vector, then that means that the magnitude of B should equal 1. And we test that by finding the magnitude of B, so that's equal to the square root of root 3 over 2 squared plus 1/2 squared. If I carry that through, that's the square root of 3/4 plus 1/4. And this is looking pretty good. This is the square root of 4 over 4, or 1, which is equal to 1. So this is a unit vector. So just to get the concept of what a unit vector is really important. But really, because we've spent all that time on the unit circle, really just think about unit vectors are just every single vector that can come from the origin and land on the unit circle. So this is nice. This is where the unit circle kind of comes back and maybe haunts us for some of us, but maybe reinvigorates our love of the unit circle. So let's see, there are some special unit vectors that we talk about. And we've seen these before, but we've seen them by a different name. So the special unit vectors we call I and we call J. So I is defined as the unit vector that is in the x direction. So the vector I, and you'll see different notations for it. Sometimes you just see the letter I written. I think this is a little confusing because it kind of looks like the number I. So what sometimes people do is they'll put a little hat over it, or sometimes what they'll do is they can just even write an arrow over it. I might kind of bounce between all of these. I'm partial to the I with the hat because that's what I was taught, but I'll try and get all of them in there from time to time. Anyways, this vector I is defined in component form as 1 unit in the positive x direction and 0 units in the vertical direction. So it is 1 unit in length, and that's it. It's drawn for you right here. I encourage you to draw this for your own notes. Draw a little grid and just emphasize that it's 1 unit long. J is the same type of a thing. You could see a J, you could see a J hat, you could see a J with a little vector arrow over it, and that's equal to 0 units in the x direction and 1 unit in the vertical direction. So those are our unit vectors, and we can write them in what's called unit vector form, which is this right here. We would say this is 3i plus 2j, and that just means that we have 3 of the unit vectors in the x direction and 2 of the unit vectors in the y direction. And really this is just another form of vectors that we've seen. It's really similar to component form. This 3i plus 2j, that's the same thing as 3. This 3 is a scalar multiple of the unit vector I, plus 2, which is another scalar multiple of the unit vector j, which is 0, 1. And so this is going to be the same thing as 3, 0 plus 0, 2. And so this whole vector right here we can express in component form as just 3, 2. And I don't think that should be all that jarring, because really what we're doing is we're just taking these components and we're slapping an I and a j in front of them. But I guess the concept of what's going on is what's important. We really are thinking of these i's and j's as unit vectors, and we're just doing scalar multiplication with them. Notice that we can't combine these together because they're not like terms. One's an I, one's a j, but we also can't combine them because they're talking about different directions that are completely perpendicular to one another. So that concept is important too. So in general, when we're talking about unit vector form, we can take any vector a1, a2 and write it as a1i plus a2j. And we could kind of go back and forth between the different forms. So let's look at a couple of examples of what we can do with this. If we want to find out which of these things are unit vectors, all that we're going to do is we are going to just test for the magnitude. Another way of saying that is this thing on the unit circle? So let's do that. Let's take the magnitude of this vector. It's just going to be the square root of 0 squared plus negative 1 squared. And that's going to equal the square root of 0 plus 1. And so A is a unit vector. It is 1 unit in length. How about B? Let's check the magnitude of B. So we're going to take the square root of negative 1 over root 2 squared plus 1 over root 2 squared. And that's going to be the square root of 1/2 plus 1/2, which is the square root of 1, which is equal to 1. And yes, sure enough, this is unit vector. And this actually is the same thing as, I think that would be on the unit circle. We have a negative x, a positive y, second quadrant. That's going to be the same thing as 135 degrees. So that's your sine and cosine values right there. So that's it. Why don't you try an example for 3 examples for your own. We're finding the length of these vectors. If they're 1, you've got yourself a unit vector. So pause the video and resume when you're ready to check the answers. All right, so here are my answers. Only one of these was a unit vector. So yeah, there it is. Hopefully that made some sense. Check my work, see if I made any mistakes, and let's keep moving. So a couple more simple examples. We want to just write these things in unit vector form. They're in component form. And really, if this looks easy, it's probably because it is. All we're doing is we're taking the components and we're writing it in unit vector form. So 2 and negative 1 would become 2i minus 1j, or just j. And then for b, this would be negative 3i minus 4j. And that's really it. So I got nothing else to say about this. So why don't you try it? Try these brain busters. See if you can write them out in unit vector form. All right, here it is. And next example. We want to go backwards, so we can write it in unit vector form, we can write it in component form. And I believe we can do it. So I'm going to take my components, 3 and 5. Boom, that's that one done. B, I'm going to take my components, 5 and negative 4. Boom, that one's done. Now notice, like, the only way that you might be tricked is if the i's and j's were reversed. Typically that's not going to happen though, because it is the convention to put the i's before the 4's or before the j's. But just keep an eye out and make sure that the I vector goes on top. All right, why don't you try a few more examples. Write these in component form before our last challenge. And there are your answers. Last problem that we want to do here is we want to write a unit in unit vector form, so with the I and the j, the vector that has a magnitude of 1 and a bearing of 150 degrees. So this is a great problem. And this is basically, believe it or not, a unit circle problem. So when I'm thinking magnitude of 1, I really want to think unit circle. This is why the unit circle is really important and why it's really helpful for doing vectors moving forward. It really helps us get an idea of ratios and bearings and things like that. So let's just think about the xy plane. And if I have a bearing of 150 degrees, this is where the unit circle doesn't really work well with bearings, right? Because I'm not starting from the x-axis, I'm starting from north at 0 degrees. So I'm going around 150 degrees, which is going to be, it's going to be past 90, and and it's going to be another 60 degrees. So this is my bearing of 150 degrees. And I want this magnitude to be 1. And this is some vector. So what I'm interested in is what is the horizontal and vertical components of this vector. And then I'm interested in what is, so then what would the unit vector form be if I can find the components? So, I mean, at this point, we have ourselves a right triangle. There's a reason why I chose 150 degrees. So what I'd like you to do is I'd like you to pause the video and see if you can't finish this out. Find the unit vector form of this unit vector. And then when you're ready, you can resume the video and I'll finish this thing out. Okay, so here's how I envision this. Right now I'm seeing if this is 150, this is going to be a 60-degree angle. And so this is, all of this is going to be my special trig. So my y is going to equal the sine of 60 degrees. And the x is going to be the cosine of 60 degrees. And so I know my special angles here, and I know that the sine of 60 degrees is equal to root 3 over 2. And the cosine of 60 degrees is equal to 1/2. So that means now since I'm in this fourth quadrant, I have to kind of keep in mind what my positives and negatives are. This is going to be a positive x and a negative y. So then the unit vector form, we'll just write the component form. That would be a positive 1/2 and a negative root 3 over 2. So the unit vector form would be 1/2 I minus root 3 over 2 j. And there it is. Unit circle. You thought it was done, but it's back.